So today we will start with a question. Okay, so there is something which is called as Hamming distance. So I'll tell you what is Hamming distance. First of all, this is a kind of distance only, and this Hamming distance is calculated between two numbers, okay, n1 and n2. For the sake of simplicity, you can assume that the two numbers are non-negative, okay. And what is the Hamming distance between two numbers? Hamming distance between two numbers mean that if I represent n1 in binary form and n2 also in binary form, then the number of positions where bits differ. Number of positions in n1 and n2 where the bit values are where the bit values are different. So either it can be 0 here, 1 here, or 1 here, 0 here. That is the count of that is equal to the Hamming distance of two numbers. Okay, I'll take an example, maybe that can help. So let's say the binary representation of n1 is 1 0 0 1 1 0 1, and the binary representation of n2 is 0 1 1 1 1 1 0. If I have to calculate the Hamming distance between n1 and n2, then as said, the number of positions where bits differ. So if I take a look at this position, do the bits differ? Yes, they do. Do they differ here? Yes. Do they differ here? Yes. Do they differ here? They don't. Do they differ here? They don't. Do they differ here? Yes. Do they differ here? Yes. So at how many positions did they differ? They differed at 5 bit positions. So the Hamming distance of n1 and n2 in my case should be equal to 5. And it is Hamming distance is defined for two numbers, and before calculating Hamming distance, for sure you have to take into consideration their binary representation. Only then you can fix a position and check, fix a position, check, fix a position, check. Can somebody tell me what is the Hamming distance between 2 and 7? Quick. Okay, you're also getting 2. So what is the binary representation of 2? It is 1 0, and 7 it is 1 1 1, and I can pad it with 0. So at this position there is difference, this is same, and at this position also there is difference. So the Hamming distance is 2. So now the question says that you will be given an integer array containing non-negative numbers. All the numbers are greater than or equal to 0. And now the question asks you to find the sum of Hamming distance between all ordered pairs. Sum of Hamming distance between all ordered pairs. So how many ordered pairs are there in an integer? In an array. If I give you an array and I ask you that how many distinct ordered pairs means distinct pairs. So if you have taken A4, A5, you should not take A5, A4 again. Okay. And also you cannot take A4, A4 also. Pair means AI, AJ such that I is not equal to J. And once you have taken AI, AJ, you should not take AJ, AI again. So how many such pairs are there in an integer array of size n? Can you tell me? So if the array looks like 2, 4, 6, then first pair is if you club this with this, second pair is if you club this with this, and third pair is if you club this with this. Apart from these three, are there any other pairs? Yes, NC2 is the most perfect one. Here in this case also it is 3C2, which is 3. So there are 3 pairs. So 2 and 4 will have some Hamming distance. 2 and 6 will have some Hamming distance. And 4 and 6 will have some Hamming distance. What I want is the sum of these. What will be answer for this case? Can you quickly do some maths and tell me what is the answer for this case? So 2 is like 1 0 and 4 is this. So here the bits have differed, and here also the bits have differed. So this is 2. This thing is 2. 2 is again like this, and 6 is like this. So here the bits have differed, here they are same, and there also they are same. So here it is 1, and if I take a look at 4, it is something like this, and 6 is something like this. So here the bits are same, here the bits differ. Are you getting 4? You should be getting 4. Yeah, so as simple as that. This is what the question is. Let us start solving it now. Okay, so which approach will you first convey? If this question is asked to you in an interview or by a random guy, which approach will you first convey? Brute force. Very good. What is the brute force approach? Brute force approach is to simply consider all the pairs. Okay, and while you are considering any two pairs, then you can very easily compute the Hamming distance between those two pairs, and whatever Hamming distance you got, you can add it to your answer, right? So you can initialize your answer, which is your Hamming distance, to be 0, and now you will consider I from 0 to n minus 1, and j, in order to consider ordered pairs only, will vary from I plus 1 to n minus 1. Now here inside you have a particular value of I and a particular value of j. Okay, so what is the next thing that you would want to do? Now I and j are given to you. Now you want to find out the Hamming distance. Can you find out this Hamming distance in order one time? Yeah, you can take XOR and do that, but my question is it possible to do that in order one time? No, you have to iterate through all the bits, right? So see, one simple way is that you can have a function called as find Hamming distance. So this find Hamming distance function is written by you. Find Hamming distance. It takes ij and it computes the Hamming distance between array I and array j, and it returns that, and you add that value to your answer, and finally you return your answer. So this process of finding Hamming distance somehow means that you have to inspect all the bit positions of array I as well as all the bit positions of array j. So can you talk about the time complexity of this method? Just this method. What is the time complexity of this? 64. Assuming that the integers are 64 bits. So you can very easily do that. So what will be the overall time complexity of this algorithm? It will be 64 into n square. Cool. So this will time out for a very large n. So can somebody suggest a better way? This was quite a brute force approach where you are playing at the level of pairs, playing at the level of numbers. But can you play at some other level, which I have told you before? Can you play at the level of bits? Is it possible? The hint is think at the level of bits. So let us take a look over here. See, what I am saying is, let's take a look at this example itself. So one way to solve this problem was what I just did, which was a brute force approach. Simply take all the pairs, calculate Hamming distances, and keep adding them. What you get, that will be your answer, right? Now what I am saying is, instead of considering all the pairs and playing at the level of numbers or pairs, whatever you say it, why don't you play at the level of bits? So what do I mean when I say play at the level of bits? Just think of it in this way. So there are three numbers. All in all, there are three numbers. So I have a 2, I have a 4, and I have a 6. So in this answer that you have got, 4, how much is the contribution of bit 0 of all the numbers? Just read through this line, and this is very important. In this 4, how much is the contribution of bit 0 of all the numbers? Can you tell me that? 0. Very good. Because what I mean by that is, when this collided with this did not give any help. When this collided with this did not give any help. And when this collided with this did not give any help. So the contribution of bit 0 was 0. Okay. If I talk about contribution of bit 1, if I talk about contribution of bit 1 of all the numbers, can you tell me how much is the contribution of bit 1 of all the numbers? 2. Very good. Because the collision of this would have gained a contribution from this. The collision of this would have gained a contribution for this. Only the collision of this would not have gained a contribution for this. So there are two contributions over here. So see, first I did my job for B0, then for B1, and similarly I think I can do it for B2 also. Can you tell me what will be the answer for B2? What is the contribution of bit 2 in the overall answer? That is also 2. Collision of this and this, 0 and 1 would have given me 1. Collision of this and this, again 0 and 1 would have given me 1. Only this collision would have given me 0. So 2 contributions here also. So the sum of this is exactly equal to this. Yeah. So instead of playing with numbers, I have played at the level of bits. So I have said that, hey, I'll fix a particular bit, let's say B1, and I'll scan B1 of all the numbers. I'll scan what is there at bit 1 of all the numbers. And once I have scanned that, then I think it will be very easy for me to tell that how much will be the contribution of that bit position. Right? Can you tell me how do I figure that out very easily? Let's say you are scanning bit 1 of all the numbers. There are n numbers, okay? And you saw that there are x out of n numbers for which the b1 value is equal to 1. Listen to my question very carefully, okay? You scanned all the n numbers for b1 bit position and you found that out of n there are x numbers whose b1 has a value 1. So can you tell me what will be the contribution of b1 if that is the case? X into n minus x. Yeah, frequency of 1 into frequency of 0, because it would never ever happen that if you are scanning bit 1 and let's say there is a number like this and another number like this and let's say another number still like this. So if you choose any two pairs from these three numbers, if you choose any two numbers from these two pairs, will they have a differing bit at b1? Will they have a differing bit at b1? Yes, no? They will not have. They will clearly not have. Similarly, if let's say you had something like this, if you choose any two numbers from here, will they have a differing bit at b1? They will not have. So does it make sense to choose the two numbers from this bucket or the two numbers from this bucket? No. You would always want to make cross bucket choice. Okay? And how many cross bucket choices you can make? So if there are x numbers whose b1 is 0, then that if let's say there are x numbers whose b1 is 1, that automatically means that there are n minus x numbers whose b1 is 0. So total number of choices will be frequency of this into frequency of this, which is x into n minus x. And you can add this thing to your answer. If this is the case, then what can I do? If you write the code, can you tell me if you were to implement this approach, how much would have been the time complexity? Yes, it will be n into 64, assuming that there is nothing to assume, because even if you have long integers, at max it can be 64 bit and not more than that. Okay, so how to implement it? Okay, so let me ask you some simple questions for that. If let's say you are trying to inspect that how many numbers are having, let's say, ones at b0. How many numbers are having ones at b0? How will you do that? What is the way to do that? Can we use a mask? Can we use a bit mask which just has 1 at b0 and 0 at everything else? Yes. So I can simply use a bit mask, okay, like this. So to scan at this position, my bit mask should be something like this. And I will take the AND of this with this, and if that AND is 0, that means this bit was 0, and if that AND is non-zero, that means this bit was 1, right? Is it clear to everyone? Yes, no? Bit mask is the, it is the heart of bit manipulation questions. You cannot get your job done without that. So let us scanning. You can scan from here also, you can scan from here also. Let us scan from most significant bit. So most significant bits position can be 63. Okay, I greater than equals to 0, I minus minus. So first I'll create a bit mask. Okay, so I'll have a mask, long mask. What should be the value of this mask? If I am trying to scan the 63rd bit, 63rd column. What should it be? Yeah, 1 left shifted by I units. It should be 1 left shifted by I units, right? Now what will I do? Now I am supposed to count that how many numbers are there that are having 1 at this particular bit position. So for that, what will I do? I'll have a count initialized to 0, and then I'll loop over all the elements from I equals to 0, I smaller than n, I plus plus. Okay. So this count's responsibility is to keep track of that how many numbers I have got which are having 1 at bi. Okay. So how do I detect that? If I see that mask bitwise AND with array I. So if this thing is non-zero, what should I do? Should I change my count? Yes, I must change. And what should it become? Count plus plus. Once this loop is over, then this count would have contained that at bi, how many numbers are having bit value as 1. Okay. So if count numbers are having bit values as 1, then n minus count numbers will be having bit values as 0. So this is frequency of 0 and this is frequency of 1. So whatever this is the contribution of bi, and the contribution of bi I can add it to the answer, and finally I can just return my answer. So do you realize this thing, like it's just about determining that how you are going to play at the level of bits, and once you have determined that, the code becomes extremely simple. Okay.